Well, good afternoon, everyone. Thank you so much for joining us today. It's a pleasure to have you here with us today as we explore some long-term cover crop research up at the Gilmore City Research Farm. So thank you again if this is your first field day for attending, and thank you again if this is one of the many that you have attended so far this year. We really appreciate all the feedback that we've gotten from everybody who's attended. We really hope that you enjoy kind of this virtual visit to the field here as we discuss the research that's going on up at this particular site. I'm Liz Ripley. I'm the Conservation and Cover Crop Outreach Specialist for the Iowa Learning Farms. We're based on campus at Iowa State University. We were established in 2004, and our goal is to build a culture of conservation by working with farmers and researchers to implement practices that improve water quality and soil health while remaining profitable. And this is made possible through our great partnerships, and that includes with the Iowa Department of Agriculture and Land Stewardship, Iowa State University Extension and Outreach, Leopold Center for Sustainable Agriculture, Iowa Department of Natural Resources, US EPA Section 319, Conservation Districts of Iowa, Iowa Farm Bureau, Practical Farmers of Iowa, GrowMark Inc., Iowa Agriculture Water Alliance, Iowa Corn, and the Iowa Nutrient Research Center. So just a quick bit of housekeeping. I do ask that you remain muted and your videos turned off during the video portion and the presentation that will follow. Once that is concluded, you will be invited to actually unmute and ask any questions that you have, but you may also submit those at any time via the chat box, and I'll get those asked of our presenters following the video and presentation. A little bit later this afternoon, you will be receiving an email asking you to evaluate today's field day. It's very quick, 5-minute survey. But this is the start of the conversation. One of the benefits of being on a virtual platform is that we can record. So this is indeed being recorded. So you will be able to access the information that's discussed today following it with the link that'll be provided in that evaluation email, as well as on our website, iowalearningfarms.org. We're also offering free neck gaiters when you return your evaluation. You just provide us with your mailing address and we'll get that sent off to you. So we have a great agenda for you today. We have with us today Dr. Matt Helmers, Director of the Iowa Nutrient Research Center, Emily Waring, a Graduate Research Assistant here in the Department of Agricultural and Biosystems Engineering, and Carl Pederson, an Agricultural Specialist, also in the Agricultural and Biosystems Engineering Department here at Iowa State. So without further ado, I will play the video.
Hello, I'm Matt Helmers with Iowa State University Extension and Outreach, Professor in the Department of Agricultural and Biosystems Engineering, and Director of the Iowa Nutrient Research Center. Today we're at our Gilmore City Drainage Water Quality Research Facility. This site was established in 1988, set for drainage water quality monitoring in 1989. Then there was no flow in 89, but flow started in 1990. And we've been monitoring at this site since that point in time, looking at the impact of different nitrogen management practices, cropping systems, and their impacts on drainage water quality, specifically nitrate loss. So today we're going to talk a little bit about how we monitor that drainage water quality and what some of our results are, specifically related to implementing winter cereal rye cover crop on this site. Okay, this is one of our drainage water quality monitoring sumps. So at this site, we have 72 individually drained plots. Each of the plots is 50 foot wide, 125 foot long, and down the center of each of those plots is a perforated tile line at about 3 to 3.5 foot deep. Each of those lines comes into one of these sumps, and down in the bottom we have a garden variety sump like you might find in a lot of basements in Iowa. And then we have a sump pump in there, and we pump that water out of there, and then that water's pumped, and it's pumped through a flow meter right here. And so with that, we can record how much water is coming out of each of these individual plots, so we can quantify what's the drain flow associated with the treatment that we have there. One of the other important things that we want to do is to collect a flow proportional water sample. So we want a little bit more water when there's more flow happening, so that we can quantify kind of the flow weighted nitrate concentration, and then ultimately calculate a nitrate load that might be exiting this system through the drainage. And so right here you'll notice this tubing in line in that PVC piping is a small orifice so that when that water is pumped, we get back pressure in that piping, and that forces a small portion of all that water into a sample container. And then about once to twice a week, our research group will come out and take a representative sample of that, discard the rest, get ready for the next week. We'll take that sample back to the lab and analyze it for nutrients. What we're primarily looking at is nitrate. We've also looked at phosphorus at this site, but this is a passive way to collect a flow proportional water sample so that we can get a good representation of the concentration of nutrients, and in this case nitrate, nitrogen, that's being exported out of that drainage system from the treatments that we have implemented on those plots. As I said, this site's been ongoing. We've been monitoring since 1990. We've looked at a variety of different nitrogen management practices, cover cropping practices. So information from this site was used extensively in development of the Iowa Nutrient Reduction Strategy non-point source science assessment. So many of those in-field practices, whether they be timing of nitrogen application, rate of nitrogen application, or even cover crops, research data from this site was used in that to quantify the impacts of those various practices. So not only to the Iowa Nutrient Reduction Strategy, other states have utilized information that's been collected at this site. We're out here in a corn residue plot, October 12th, 2020. And so one of the things that I think is interesting, about 5 years ago, we've been studying cover crops up here, winter cereal rye, for over 10 years. But one of the things that we did about 5 years ago is we switched from drilling the rye in after corn or soybean harvest to interseeding that rye about in the Labor Day time frame. And so one of the things, in most years, this might be the time when we're drilling it, but this year we actually have some growth. So I think that's one of the interesting things that we've seen, and we've probably seen a little bit more consistent cover crop growth since we've done that. But one of the other interesting things this year, it's been really dry in Iowa, and certainly this site has been no exception, but we did get a little bit of rain right before we seeded this cover crop. And as we're out here today, again on October 12th, we got about a ½ inch of rain last night. And so we'll probably see this cover crop really start to take off here in the next couple weeks. Okay, I'm going to ask a graduate student in our Agricultural and Biosystems Engineering department, Emily Waring, to come on in. And I'm going to ask Emily a couple of questions. So Emily's been working at this site for a number of years. So Emily, you've kind of seen the shift from us drilling in the rye to hand seeding it. Maybe you can describe how we're seeding this and what seeding rate we have.
So yep, we hand seed it into a standing crop around Labor Day, like Matt said, and we do it at 90 pounds per acre. And then if you're wondering how much weight per area or above ground biomass we have, what I'm standing in I think would be about 500 pounds per acre. We'll measure that in the spring, but based on what we've seen throughout the years, this is what I think that would look like in terms of cover crop height and density.
Okay, as I talked about, we were talking about the sump and the drainage water monitoring. I mean, one of the things we're doing out here is trying to quantify the impacts of some of these management practices on nitrate loss. And so in particular here we have this winter cereal rye cover crop, and so we're able to compare nitrate loss, nitrate concentration, where we have a winter cereal rye cover crop and where we don't. And we've seen, even at this site where some years we don't get a lot of growth, we still have seen 20 to 40% nitrate reduction when we have that cover crop. And we'll talk a little bit more about that during the virtual field day. But let me ask, Emily has been doing some work looking at some of the soil health measures. And so maybe Emily, you can share a little bit on soil aggregate stability and aggregate size that we've measured in the cover crops or non-cover crop plots.
Yeah, so we measured soil aggregate stability, which tells you about soil structure. And we saw that with an addition of a cover crop after 5 years, we saw significant improvements to aggregate stability. So that means that your soil can stay together, which would improve things like infiltration and nutrient cycling. So we were happy to see that even at this high organic matter site, we saw significant improvements just after 5 years.
Okay, now I'm here with Carl Pederson, that's an ag specialist with the Department of Ag and Biosystems Engineering. And Carl is the one that makes things happen up at this this research site. He does all the agronomic management, helps with all the troubleshooting and everything else we need to get done. But I wanted to ask Carl a couple questions. Carl, maybe you can describe how we manage this cover crop. Emily talked about how we seed it, but then at some point in time we have to terminate it. And maybe you can describe about when we terminate it compared to cash crop planting and what you use to terminate it.
Yeah, good question, Matt. So what we do up here, we try to get in and terminate this rye crop with a Roundup or a glyphosate formulation. And what we want to do is time it at least a week before we plant corn. And then we do the same thing for soybeans, but we're not so critical about when we get that termination done. We can, depending on the weather, we can get out and we can terminate it just before planting, or maybe up to a week after planting for the soybean crop. But we do use the same glyphosate formulation for that as well.
So one other question I had for you, Carl. So while we don't get a tremendous amount of fall growth up at this site, have you seen any problems when you've combined beans close to the ground with any of the rye little green
Excellent
parts of the rye?
question. Yeah, no. When I have had some good growth in the soybean crop, that's never a problem for harvesting soybeans. Typically, it'll just land on your cutter bar. It's not quite tall enough to cause any problems with any sticking to the bean head at all. It literally just blows out the back of the combine, but it'll flow right through and you'll never notice it at all. Even if we do have a good lush growth, it looks great.
And I would say that's even with a combine that isn't maybe the most modern technology.
That's right, that's right. We got it. It is a little bit younger than me, but it is an old combine.
Yeah,
but
yeah.
Yes, it's a 1977 technology. But it does great for test plots, and if we put a modern combine out here, the combine would be literally as big as the test plots we have here.
Okay, just to describe a little more about this site. We're along Highway 3, as I said before, Gilmore City, Iowa, but it's kind of along the Highway 3 corridor in Iowa, in north central Iowa. And so, this site, as I talked about, has really helped us look at various practices and their impacts on drainage water quality. I'm actually standing in one right now. Over 10 years ago, we implemented a treatment for plots here, 4 replicates, where we're looking at a forage mix. So it's orchard grass and then clover mix. And so we can look at the impact of that on nitrate loss, and we see dramatic reductions in nitrate loss when we have this. So illustrating, the more living roots we can get on the landscape, the greater reduction we can see in nitrate. Also within this general area, there are a number of wetland sites where we're looking at our folks at Iowa State and specifically put in by the Iowa Department of Agriculture and Land Stewardship under the CREP program, looking at denitrification wetlands for removing nitrate. So we talked about, some of these practices can help us reduce that nitrate that gets in the tile line, but we still have some in that tile line, and so if we can route that through something like a wetland, we can reduce that downstream nitrate delivery. And so we've been working with some farmers in the area here to document what land management practices are happening upstream of those wetlands as well. So it's been a very unique opportunity and really highlights the importance of kind of working in the field as well as some of our edge of field practices if we want to make nitrate reduction gains.
All right, so at this point, I know Matt's got some slides he wants to share to kind of go in a little bit further on some of the research that's happening up there.
And I can show those, but if anybody has any specific questions, you're welcome to ask those, because I like to say this time is yours, so let's get the questions asked. But I just thought I would share a couple slides. I'll try to minimize them. I'm channeling our colleague Ann Stout that would say, don't show too many graphs, Matt. But just to kind of illustrate the type of data that we've collected at this site and some of what we've seen. And so the first slide here just illustrates kind of the range in drainage, nitrate concentration, and nitrate loss that we've seen over the 30-year period at this site. And this is under pretty much the same nitrogen management system, an early spring side dress. This is the combined effect of a corn soybean system. And so you can see that our drainage is quite variable from a high in 2018. Actually, 1993 should have been the highest drainage, but there were a few, I think, flooding issues there. But we can see a couple things here. We can see, when we get a lot of wet years like we did in the early 90s, we can kind of flush nitrate out of the profile. But then if we see like a year like 2013 after a drought, we see that spike or that increase in nitrate concentration. So I talk about, we need to be thinking about that for next year. And that's why this fall, if you got moisture and if you got cover crops in, they probably can help us mitigate that risk of increase next year. I mentioned that we, we've studied different nitrogen application rates. And so this just illustrates this curve here is using the original data from 1990 to 2004, looking at the impact of nitrogen application rate to corn in a corn-soybean rotation, to the combined nitrate concentration, flow-weighted nitrate concentration from the corn-soybean cropping system. And as we would expect, the higher the nitrogen application rate, the more nitrate-nitrogen or higher nitrate-nitrogen concentration we get. This is, I bet if you've seen me talk before, most people have probably seen this graph, but actually you are getting some new information on here. I've added in some of our more recent data at both Gilmore City, Nashua, and the Northwest Research Farm to kind of see how with, a little bit more recent data, maybe a little bit higher crop yields, what does that look like? And they really kind of tend to still fall in that same range of what we saw from 1990 to 04. I'll just comment quickly as we talked about on the slide set, we've seen nitrate reduction with our winter cereal rye cover crop. And so one of the things we have at this site is we have both a conventional till and a no-till, and then we have a tillage with cover crop and a no-till with cover crop. And so this is comparing the conventional till to conventional till with cover crop. And again, we're seeing, we're documenting nitrate reduction benefits where we're seeing that cumulative nitrate loss being lower under that conventional tillage with rye. So one of the things is that in 2010, we implemented no-till on a certain number of the plots. And so we've been studying that. So we're getting at a 10-year period of no-till. And so one of the things is that early in that, the no-till and no-till with rye, we didn't see much difference between those. But then the last 4 or 5 years, we're starting to see some increased benefit of that cover crop. I think one of the reasons, this is part of Emily's work, so I should have let her talk through these slides, but I guess she can answer the tough questions. But one of the things is that at this site, in that first 5-year period, when we implemented no-till, we saw a nitrate reduction with no-till. But the second 5-year period, we've not seen that. So if you look at these curves, we get to about 2015, and then they're really parallel from there on. So we get that reduction in that, at this site, we've seen a reduction in that first 5 years of conversion to no-till, but then that subsequent 5 years, that nitrate loss between conventional tillage and no-till has stayed the same. Okay, I think I'll stop there. I have some other slides in case there are specific questions that come up that folks might be interested in. We've done a little bit more work at a couple other sites on timing of nitrogen application. And so could talk about that, but first throw it out to any questions.
And we do have a couple. The first one's actually for Emily. So Emily, if you want to go ahead and unmute and turn on your video there. There's a question about aggregate stability, how you evaluated that. So what did you use and what sort of increases did you see with cover crops?
So we did the Yoder method. So you essentially get like a 6-inch sample, with a lot of diameter to it. So you provide an opportunity to see the actual soil structure. And then we take it to the lab and we wet it for 10 minutes, and then we oscillate it for 5 or maybe those are split. And then we see what remained on those sieve sizes. So in both no-till and chisel plow, we saw that the cover crop influenced the mean weighted diameter. So the amount of, or the average size of soil that kind of survived the wetting event was increased with a cover crop.
I'll put a little plug in there that Emily and Morgan Davis did an Iowa Learning Farms webinar, a little bit more specifically on some of those topics. So one of the things that that was unique in 2018 and 2019 is Morgan Davis, that was working with Marshall McDaniel, also made greenhouse gas measurements at this site, both from the different tillage treatments and cover crop treatments. And so Emily and Morgan did a webinar on that this summer, just kind of specifically on some of those joint measurements there.
So sticking on that topic of soil aggregation, is the increase in soil aggregation after 5 years of cover crop found in both the tillage and no-till scenarios?
Yes, and I actually misspoke that day. We took those measurements in 2017. So it was after 7 years of a cover crop, but yeah, it was seen in both no-till and chisel plow. And we saw like the cover crop growth, so the amount of above ground biomass was the same in chisel plow or no-till with the success of the cover crop growth.
I'll just mention on the cover crop management, especially for that one that we've called conventional tillage with rye. We did change that management in about 2015. So the first 5 year period, what was done was right after corn and soybean harvest, Carl would till that and then drill the rye in, and then we'd just terminate the rye in the spring. Okay, well, it's not as easy to do if you're interseeding in early September. So what was done was that was not tilled in the fall. It was interseeded, not tilled in the fall, but then it was tilled post termination in the following spring. So there was a slight change in that management of that conventional, what we've termed the conventional tillage system with the winter cereal rye cover crop.
So Emily, is the interseeding of the rye giving you better establishment and biomass going into winter than when it was being drilled? Or maybe that's a Matt question.
No, ask Emily. No, ask Emily.
Yes, definitely. We were essentially seeing like no growth in the fall. And then now, so we were seeing maybe like 200 pounds per acre ahead of corn. And then now we see like an average of like 1,000. So we see a lot of fall growth now that we started hand seeding in the fall, because we can get it on like 2 months earlier.
I would just say that there were many years when I would ask Carl, is there any growth on the cover crop? This was when we were drilling it. Is there any growth on the cover crop? No, hasn't grown. So, now I will say we got lucky this fall because, we were watching the weather and, Emily and the rest of the crew was able to get that down right after we got some rain. And then we did, as I said, on October 12th, the night before that, we got some rain. So that helped the growth this year. Certainly recognize some people probably would not have been as fortunate.
And clarification on the interseeding, there's no incorporation on that, correct? It's just surface applied.
That's correct. Yeah.
Okay.
Just walking. Yeah. Yep. Yep.
It's like, I know how it's done, but for those that aren't.
Yeah, that's right, Liz. It's just how you taught Emily how to do it. So.
Yeah.
Is there any specific variety of rye that you've been using for this, or any comparison of varieties to see how they go or perform?
I think we've always used the same, but that'd be Carl.
Yeah, we've not looked at very different rye varieties. I do see somebody on here that might be able to answer that, what they've seen with some of their work for the best winter cereal rye growth. I don't know if Keith Kohler is willing to answer a question or has a microphone, but you got one of the experts there on what they've seen from their years of research.
So I've got one here for Carl. I'm gonna toss this one his way. As you're harvesting those different plots, and Any differences in the yield between the with and without cover crops, or the different tillage practices? How do those compare?
So I don't have the yields tabulated yet from this year, but yes, we do see some variability in the yields. I don't want to say there's a great effect from the cover crops, but we do notice a little bit decrease in yield just on that site. The problem with our site up there on the soybeans anyway is we have so much drainage. We are very drought sensitive, I should say, because with a tile spacing every 25 feet, we dry out rather quickly. And this year was a big problem for drought. And I want to say our yields really diminished just because of the drought, not because of our treatment effects. So corn yields were better, and I've been happy with them. Back to treatment differences, I think Matt may have that information on a graph somewhere and be able to publicly show that. But we do see a little bit of treatment effect, but not a great amount.
Yeah. What I was gonna, I had pulled it up just to, because I figured there might be a question. We've seen at this site a little bit of a reduction, some years statistically significant, between the conventional till and the no-till. And so we've seen a little bit of a yield drag with no-till on corn at this site. A little bit with winter cereal rye, but I would say more of it's kind of the tillage impact. And so, I think there are things we could do to perhaps help overcome that in the future, but that is kind of what we've seen. That's one reason why, we did want to look at the rye with some tillage, because, that may, in that part of the state, that may be a little bit more something people might be willing to adopt, because they're able to do a little tillage to help warm up that soil. I think that the potential to do strip till would be even better. That you could do cover crop with strip till in this area could probably work very effectively.
And for clarification on when, is the tillage done in every phase of the rotation, or is it only following corn or only ahead of corn?
They're in the convention, in what we've termed conventional tillage. There is some tillage done before corn and before soybeans. Carl can probably, I should have let Carl can answer that, what the specific operations are.
Yeah, I can tell you. So we have the chisel plow treatment up there, and that's where we do the chisel plows going to soybeans. It'd be corn stalks that we do in the fall. We do not touch the soybean ground. I'd like to leave that there to prevent any wind erosion. But then I do follow up with a traditional, field cultivator in the spring for the soybean or the corn crop. People were asking about the rye when we terminate that. We do tillage in the spring, and I try to simulate a heavy tillage like a chisel plow, but I just use a tandem disc and I go over it twice and try to give it a good deeper tillage to simulate a chisel plow treatment.
And Carl, I guess it might have, I guess he wrote it to everybody, that it was Elbin rye that was used.
Correct.
And there's a question about the rotations. Are they all corn and soybeans? Do you have corn on corn? What's the crop rotations for those different plots?
Right now, all of them are corn soybean rotation, and we have corn and soybean present in any given year. So for each of the treatments up there would officially be 8 plots in each treatment. 4 of them would be corn plots and 4 of them would be soybean, and then they rotate back and forth.
And what's your N application method and rates for your corn up there, Carl?
So we got 150 pound straight nitrogen treatment for all the corn up there. And we do have the fall nitrogen application with anhydrous ammonia, as well as the spring nitrogen anhydrous ammonia application.
So
we have one treatment that is, I think it's 100 pound anhydrous ammonia with a 50 pound side dress later on that summer.
And one thing I would mention is that we, if you were to look at some of our previously published studies prior to 2015, a lot of that nitrogen was using aqua ammonia because there were challenges with metering the anhydrous. But since then, we've gotten some better metering equipment, and so now our nitrogen up there is anhydrous injected.
Because you were working on a small plot scale, you couldn't take the
Yeah,
big rigs and tanks out there.
No, and I mean, Carl's spent a lot of time getting one that we feel pretty comfortable can get a good, relatively uniform application down.
We're doing pretty good. We're doing as best as we can for driving 125 feet, turning it off and on. So we do have an AccuFlow system that most farmers use or familiar with. And so using GPS guidance and everything else. But yeah, it's doing very well. And we also have a weigh scale on the tank. So we actually have a redundant system for recording those measurements.
I would just say that, you know, Carl mentioned that we do fall nitrogen up there. I'll just say at that site, we don't put that fall nitrogen down till soils are 50 degrees and cooling. And, you know, really over the long term there, which is also consistent with what we've seen more recently at our Northwest Research Farm data, we see very little difference in the nitrate concentration between fall applied ammonia or spring applied ammonia. And we see really similar yields most years with those as well. And that's what we're finding again at the Northwest Research Farm as well. I would say that in areas, if we were to go in maybe southeast Iowa or, you know, other parts of the Corn Belt, you know, that would not be the case where they have more winter drainage. But most of our, you know, so much of our flow is coming in the spring of the year that a lot of years we don't have any drainage during the winter period.
So Matt, this is one about the drainage up there. Are you seeing reduced tile flows on no-till plots versus tilled? Or in other words, are there reduced nitrogen loads due to primarily to the reduction in reduced concentrations or reduced flows?
Yeah, great. Emily, you want to ask to handle that?
Yeah, so sometimes with no-till, people have seen an increase in overall drainage because you have increased infiltration, and then you will actually see an increase in nitrate loss because you have so much more drainage. But we did not see any difference in drainage amount between no-till and chisel plow. And then we still saw a reduction in concentrations. So we think that's like a microbial timing.
And really during those first 5 years, right? The subsequent 5 years, they've been, those concentrations have been closer or the same between the no-till and conventional till.
So
that's a good question.
You mentioned that you have the, I'm going to call it perennial vegetation up there. What are some of the other research goals with that particular plot that you're looking at?
So yeah, that's a good question. I mean, when we started, when we started that and put that in, golly, it's been about 15 years ago, maybe, or maybe not that long. Anyway, just wanted to see, you know, under what would nitrate leaching be under a perennial. We didn't have a tremendous amount of that data, and we wanted to kind of see what it would be if we had a completely perennial system there. You know, I think the system we have there would be somewhat similar to a forage because there are some years where we bale it, cut it, bale it, and take it away. We've not necessarily managed it for that with heavy inputs or anything, but that, you know, it would give us a kind of a representation of if we had a forage-based system out there, what might we expect from nitrate leaching below the plant root zone.
So you've got those various CREPS sites up there, and you're talking about working with landowners in the area to collect management information. Have you noticed any trends over the years you've been collecting that data to see if there have been land use changes and then any changes in the wetland itself? Yeah,
so Dr. Crumpton's monitoring the wetlands specifically. We have not seen much change in land use or even much change in inputs of nutrients in there. It's probably not an area where there's quite as much cover crop use. There are I think there are a couple in maybe the Clay County watershed that may have some cover crops, but it's not a real high cover crop use area. So we've not seen that much change in the land management through that time, and the nutrient inputs have maintained relatively stable.
So in general, this
Yeah.
plot, if you want to give a shout out to who the plots are supported by, I know, I don't know if that was in the video, but when we've held other events up there, we want to make sure we give credit to everybody that's helped keep those plots going.
So I want to first, this is a great example, and when you're out at an extension event, that's one of the first things I would mention. So boy, I've been remiss. So we've been fortunate. So there are hopefully a couple producers on here and other agricultural folks in Iowa, and I always ask the question, do you ever notice the fertilizer tax on when you buy fertilizer? And have you ever wondered where some of that goes? Well, a portion of that goes to an ag management account that goes to the Iowa Department of Agriculture and Land Stewardship. IDOLS, 30 years ago, looked at those resources as an opportunity for research and new technology development. And so, throughout those 30 years, a lot of the funding that we've had at Gilmore City has come from the Iowa Department of Ag and Land Stewardship. We've also had funding from this project was part of the Sustainable Corn Project, so that allowed us to look at a few more of the some of the soil aspects that Emily mentioned. We have had some resources from Koch Agronomic Services to look at some Centuro product on there. That was just on a couple plots, but that was one that we looked at. And then kind of for some of that more regional work, we've had support again from IDOLS for the monitoring that Dr. Crumpton does, the Iowa Corn Promotion Board for helping us collect some of the land management information in the watershed, and also that was part of a NRCS Conservation Innovation Grant in that larger area. So, golly, I probably forgot something. I mean, this is just it takes a lot of people being willing to invest in this a long time. I personally think having this length of data helps us understand how some of these practices perform under wet and dry conditions. It helps us in things like this year, thinking about what might be to come in 2021 with nitrate leaching. As I talked about, we saw after 2012, that increase in nitrate concentration coming out in 2013, and the areas that we saw maybe the biggest increase were from plots that were in soybean in 2013. So it wasn't an area that we could necessarily make a different management decision. That's why, I do think, really thinking about, it's probably too late now, but, for future years, thinking about those cover crops in those drier years may really help us. Logistically, you got to be able to get it seeded. You got to have moisture to make it grow. So I completely recognize that, but just kind of to highlight that.
And any future goals with the site now that it's 31 years old?
Yeah, 31. So I would say yes. I mean, I think we want to understand how some of these practices continue to perform over the long term. I think it's great that we now have 10 years of no-till, but we still get some questions. What about how's it going to perform when we have even longer no-till? So I think that's good. I think there could be the opportunity for some different management of cover crops. For example, some other work that we're looking at is, we're looking at more earlier season planting of cover crops. And so, some of that work's going to start at the Northeast Research Farm. There's some work up there that some colleagues are started with a perennial ground cover of bluegrass. So I think there are a lot of things that we can continue to do on these types of sites to look at, new management practices or document the performance of different management practices, or maybe some new technologies in fertilizer and some of the microbial products that might be able to help supply some nitrogen needs to the crop.
So, as we were promoting this, one of the things that was also mentioned was the use of N inhibitors.
Yeah.
Any information you'd like to share on that aspect, Matt?
I do. Yes, absolutely. Okay, so that's a perfect segue to to, and I did try to come prepared with that. Okay, so we have at our back in the early 2000s, we did look at nitropyrin at this site, and we did not see any difference in really any difference in nitrate leaching or crop yield with or without nitropyrin. Okay, what we now have a project at the Northeast Research Farm. So this is not too far away from Gilmore City, if folks can see that. Okay, and what we have there is we have a fall nitrogen anhydrous with nitropyrin, with an inhibitor. We have a spring pre-plant treatment, so spring anhydrous injected with no nitropyrin. Then we have a split application of urea and agrotane treated urea, and then no nitrogen. And so what we found at that site is really no difference between the fall inhibitor or the spring, fall with inhibitor or the spring, as far as nitrate concentration. We've also not seen any yield difference between those two. Now, as I said, when we looked at fall with and without inhibitor at Gilmore City back in the early 2000s, we really didn't see much benefit of the inhibitor. But, you know, I do think this is somewhat interesting that, you know, in this should say, I apologize. This should say 2015 to 2019. So
Oh,
this
Matt,
is
did you mean to
years.
share your screen? Sorry, we're seeing
Oh my
you.
gosh. Oh, for God's, I greatly apologize. Okay.
You were doing great. Sorry to interrupt
I'm
you.
doing great. Yeah. Okay. So, golly. Okay. So here's the data that I was trying to describe. So we have fall nitrogen with inhibitor, spring nitrogen, no inhibitor, split and no, and we essentially see no difference in nitrate leaching between those two. This data the slide should say 2015 to 2019. So it's 5 years of data. And I would say the nitrogen or the crop yield was no statistically significant difference between the fall end or the spring end. One last one though on an inhibitor is we did look at, we have looked at the Northeast Research Farm, and this one using Instinct with manure. And this is work that Brian Doherty has been heavily involved with. And so this top set of data is corn yield for 16, 17, and 18, and then the bottom one is 19. We'll just focus on the top one, because the bottom one actually we had to apply all spring nitrogen that year, or spring manure, because of getting froze up. But if we look at 2017 and 2018 at that site, so 2016, the plots that were in continuous corn with the liquid fall manure plus Instinct were actually coming off of soybean the previous year. So it's pretty tough to compare those. But if we do look at 2017 and 2018, we did see when that Instinct was mixed with the manure, we did see a little bit better yield. If we look at 3A versus 4A, we see slightly better yield when we do have that Instinct in there. So this was one of the times where we did see that inhibitor product help us a bit. So I would say it's a mixed bag that we, a lot of years, maybe most years that we've studied, we've not seen a yield impact, but we did as we looked at a couple of those years at the Northeast Research Farm with manure.
This one, I think, direct towards Emily. Have you noticed a difference in organic matter gains between cover crops and no-till versus cover crops and conventional tillage?
So we took organic matter and total carbon in 2011 when it started, and then again in 2015. And there were no differences between those, but we have not taken any since, or I haven't looked at it.
Yeah.
We have the samples actually from 2019.
Yeah, they've not been analyzed. So yeah, that would be, and that would be, to get back to your question, Liz, or somebody's question, what are the things we want to look at in the future? I mean, the one nice thing, if we can keep some of these treatments in place, like the till and no-till, we can evaluate some of these, and cover crops too. We can evaluate some of these perhaps soil carbon changes over time. which we know take a long time to see the difference on these highly productive soils.
All right, I got another one for you, Emily. This one's looking at the tile water. What average pounds of nitrogen loss per acre by the tile water have you seen in the no-till versus conventional versus the no-till with and without cover, the tillage treatments with cover crops? So how do the average poundages compare across those 4 treatments?
Matt, maybe you could pull up that slide.
Yeah, I can, because I think, because I will share my screen here in a second. This time.
I wish I knew off the top of my head.
Yeah. Oh gosh, sorry.
So, like the difference over 10 years or over 9 years was 100 pounds between conventional tillage and then conventional tillage with rye. But most of that happened between 2011 and 2017. So I would say you retain like maybe 10 to 30 pounds per acre per year, depending on a lot of factors, obviously the timing of precipitation, but yeah. And then we saw very similar relationships and kind of numbers with no-till and conventional till in the first 5 years. And then, do you want to go forward a slide, Matt?
Yeah.
So,
Which one?
no, back one.
Okay.
So no-till and no-till with rye from 2016 to 2019, it retained 40 pounds per acre.
So this is your cumulative, but on average, like what would you say is your average nitrogen loss and poundage, if you know that?
About at the, like I'll just answer because like over the 30-year period, at this site we lose with kind of standard fertilization about 30 pounds per acre per year. Now that I would say is a little bit higher than what we might see in some producer fields because those drains are 20-foot drain spacing. So it might be closer to 25, 27, under kind of a common fertilization rate.
And compared to the drinking water standard?
Oh, now that, just a second, that is, that was pounds per acre. Now, if you want to look at it, we can look at here, here's the flow weighted nitrate, oops, excuse me. So, at 150, on average, we see about 13 milligrams per liter if we follow that curve. Now it varies from year to year, as you see in this one. In a low of 1993, we were at about 7 parts per million coming out of there, and then at the high we were about 23 in 2013. Actually, this one shows it. If you look at, here's our average nitrate loss over kind of the same management over 30 years. Actually, it's probably closer to 35 pounds per acre per year on there, on the orange one.
And this would be without cover crops? Yes,
this one would be without cover crops. Yes, yep. So we would probably expect, like if it was, if it was a 10 or 30% reduction, I mean, if it was 30%, you might say 30 pounds per acre loss without cover crops, 20 pounds with. But yeah, some years like Emily said, some years we see less than that. There would be some years when we probably would see more than that.
All right. If you want to get those final questions in, we still have time for a few more. But in the meantime, if you did attend today's virtual field day for CCA credits, here's the information you need to get that credit sent in. I'll also put this in the chat so you can easily copy my email there, but that's emailing me at ejukums@iustate.edu by 5 p.m. today, and we'll get you that credit submitted. We're excited to offer another virtual field day this month. That's going to be on Tuesday, November 24th, again at 1 p.m. Central Standard Time. And this one, we're going to be talking cover crops and strip till with Mark Thompson. He farms near Badger, and we're looking forward to visiting his farm and getting that footage to host a virtual field day again on Tuesday, November 24th, just before Thanksgiving. All right, so I did have another question come in. Are beneficial fungi encouraged and or incorporated in the cover crop management? Are you doing any amendments to that?
We're not doing any amendments. No, just P and K, but no, nothing beyond that.
All right.
I think Mark Thompson's would be a good follow-up to this, because he is doing kind of making a system work in the Des Moines lobe where no-till, at least for some, might be a little bit more of a challenge. So encourage you all to tune into that. Mark's one of my favorite individuals to listen to talk. He has a passion for what he's involved with.
A follow-up question to
Yeah.
the beneficial fungi. Any reason why you haven't worked with that, or maybe are thinking about doing so in the future?
No, I probably just because not as familiar with it and haven't looked at it. So I appreciate you bringing that up, and we'll certainly kind of start to think about that a bit. Yeah, thank you.
And you can decide if it goes to one person or to everybody.
So with that,
Yep.
if you have any more questions, feel free to, again, we'll give you a couple minutes here to ask them or submit them via the chat. If not, you can always submit those questions to that same email, and I can follow up with this crew to connect you there. And so we will definitely get you connected with any follow-up questions or resources. I did have one more request to see that CCA information again, so
Okay.
I'll throw that back up as we close
I have
things
to
out
say,
today.
I do wear different clothes. I realized that today that I was wearing the same, was dressed about the same as when Jackie and Nathan were filming us. So greatly appreciate their work in getting some footage out there that day. And we thought it might be the last nice day, and then look at this week. So
Yeah. All right. Well, thank you all so very much, and we'll see you in a couple weeks.
thank you. Thanks for taking the time today.